how do you represent a ratio?
Little number over big number.
Say what?
It, like, so like for this, like the ratio of 27, so you do like 1, and then like 1 whole.
Okay, that's one way.
Fractions.
A fraction, that's another way.
Slashes.
No.
You don't do slash sideways. Sideways slash like that.
No, that's just a fraction on a
Slash.
computer.
You can write it out.
Or writing it out, exactly. So A to B, exactly. Okay, good. All right, so I just put that on the notes in case you didn't remember. So, okay, so you were supposed to do a ratio of spicy to normal. Would you agree?
Yes.
Okay, so what did you get?
What do you mean? That question is.
What ratio did you come up with?
Came up with.
Hmm?
14 over 99.
Is that what everybody got?
Yes.
What'd you get?
I want to say that. We got
15 over what? 25? Oh, 105.
Oh, yeah.
Okay, so the top, that's close. That's close. Okay. Did anybody get anything else?
No.
What?
Take it.
What did you do?
I got really excited about the fact that there were 1 in 7 trips and 21 trips was 50 grams. So I figured you were fair, and I was like 3 trips are spicy and somehow came up with 70 grams.
Some names spicy chips not bad.
Woo, melt my face. I see your thought process though. And I like that you describe it as I got real excited about spicy chips. So I'm guessing you're going to be in it for the long haul when we actually receive them, and yeah, it is optional. So
I don't get one.
well, whoever gets one, I would hope give everybody a little bite, maybe. I mean, there's got to be more than one. Okay, well, I don't agree with either one of you or any of these. No, not at all.
I mean, if we didn't get it correct, we pretty much suck.
No, not at all. Okay, what you did is you found the ratio of spicy to the total. Okay, but that's not what that's not the ratio that they were asking for. They were asking for the ratio of spicy to normal. Okay, so I believe we were at 14.1 in the other class.
Yeah, that's what we got.
Okay, so that's fine. And I would agree to round to 14 because you can't, we're not measuring 0.1 of the chips unless, since they're coming from UK, they get absolutely mangled on the way over here. But we're hoping they're bubble wrapped. Okay, but and we had 98.7, which I'm assuming that's how you get your 99
Yes.
because you rounded up. I'm good with that. So what it should have been is your 98 minus 14, which would give you 14 over 84 ratio.
I can't see it.
Oh, sorry, my bad. Okay, does that make sense?
Yes.
Okay, so it wasn't that you were wrong or that you suck. It was that you were doing a different ratio. And actually, what you guys calculated was the probability that of getting a chip,
14.
of getting the getting a spicy chip.
So there's a 14% chance I might get a spicy chip.
Correct.
Yes.
Theoretically. Okay? So, speaking of which, let's talk about some definitions. Okay? Everybody got their paper, their notes and stuff?
Yes.
Okay? What we just calculated out was theoretical probability. Okay? theoretical probability is the ratio of the number of favorable outcomes to the total number of outcomes. Okay? And that's exactly what you guys had calculated. All right? You write it like the probability of A. Okay? And here's where the notation is. Okay? So A would be the event of getting a hot chip. So the probability of A would be the number of favorable over the total number of outcomes. Sound good? Okay, so we have probability number line. Okay? It has to hit between 0 and 1. Okay? Your probability will always, always, always hit between 0 and 1. Why can it not go over 1?
Because there's not a possibility of getting more than 100%.
Because it's 100% and that's to be certain. Okay? So the Fifth Third commercials, why it's a great ad campaign about being, what's 5/3? 5/3, it's not possible. What is the possibility or probability that I am going to give you homework sometime throughout
0.
this quarter?
That's a really good probability.
No, that's 100%.
That's 100%.
You're going to have homework at some point this quarter.
I think they're like today or
No.
like every day.
No,
I
okay?
misread that question.
All right. All right. But if it's the probability of 0, it is impossible. So what's the probability that I never give you homework? 0. That is impossible. It's never going to happen.
What if something like changes inside of you? Like, man. homework
Okay.
is not
Now,
bad.
I will stand corrected. Tonight, when I hit $2.2 billion, okay, I'll come buy you guys whatever you want, but then, yes, I will be piecing out, and then I will never assign you homework again.
After $2.2 billion, you're going to hit the lottery tonight?
Yeah.
What are you gonna buy? If you do it?
I would travel around the world. I'm going to buy Mallory a house. I'll pay, she's got to keep her scholarships, but I'll pay the rest
Wait,
of
how
her
you going to travel around the
tuition.
world? In a boat or like from plane to plane or?
Little
Europe?
both. Maybe, you know.
Backpack.
Are you just gonna film or are you just gonna stay there for a while?
Backpack.
I don't know. Maybe. Because if I have 2.2 billion, who cares? I can do whatever
You're
I
not
want
gonna invest.
to
You're not gonna have
And
that
save?
entirety.
Huh?
Invest and save money. You're going to spend it all.
It's you get $1 billion cash.
You.
I
you
could
do
never
not.
spend that much
You can't
money
keep it all.
in the
You
amount. I'll tell you what. That's what we'll do. We'll work on the probability of
winning
hitting
the
that
lottery.
and how much money you need to. We'll do that.
All right.
Okay, but for right now,
Most of mine are actually
because I haven't even got my ticket yet,
going to
let's go back to math. Because chances are I'll probably be here tomorrow.
Knock on wood.
Okay, I can dream. Okay, so anyway, and then obviously if it's 1/2, it's equally likely, okay? So, outcomes. Outcomes are, we're going with all colors today. Outcomes are the different results possible for one trial of an experiment. Okay, so my experiment is that I'm going to roll this pretty pink die. okay, which actually you're going to be rolling tomorrow. So how many outcomes do I have?
1 out of 5.
No. I have 6 because I have 6 sides to it. And as for probability, just how many do I have? I have 6 sides, so therefore I have 6 different outcomes. Okay? Frequency is the number of times a particular outcome is observed. Okay, so let's say I roll the dice 3 times and I roll a 2 twice. The frequency would then be 2 because I rolled the same outcome. Does that make sense? Ringing bells? Okay. Experimental probability. Anybody remember what that is? When we were talking up top about theoretical, what you guys did today was to find the probability of getting the spicy chip was theoretical. It was based on assumptions of the average number of chips in a bag and the average number of spicy chips, right? Okay, experimental is going to be when we get our bag of roulette chips and we all sit in a big circle and those who want to participate is going to take a chip. Spicy not. Somebody's going to be tallying the results up on the board. That's experimental probability because then we use those results to come up with the probability. Okay? So it is the ratio of the number of outcomes in a specified event occurs to the total number of trials. Okay, so it's the probability of A, and it's the frequency of a favorable outcome over the total number of trials. Okay? And if you think about it, you know, there's only, how many chips do we think there's in a bag? 98? That's not very many. Okay? So, in theory, that bag might only have, 70 some, and then, so our total number of trials are only going to be 70. So, we probably will end up with a little bit larger of a probability number. Okay? And so we would do, if there's like 70 chips in the bag, then we would be doing 70 trials. Trials are the number of times the experiment is repeated. Okay? And the thing is that because with experiments, you don't usually do as many, they have what's called the law of large number. And it's a principle of probability. And basically what it says is that the frequency of the events will even out given enough trials. So basically, the more experiments you do, the closer to theoretical you get. Okay? And we'll actually, like, take a look at that when we do our experiment with the thing. We'll revisit and say, okay, we had these. What was our experiment? How many bags do we need to eat before to get it to go converge on theoretical? Okay? All right, one more quick question. So, what's odds? When you're in Vegas and you're talking to your bookie,
Your bookie?
it's what? It is a chance. It's the same thing as chance, exactly. And it is a ratio that compares the number of ways an event can occur. So your successes to the total number it cannot occur. Okay, so like your failures. Okay, so it's a success to failure. And that's what they do. And like when those who place bets like on football games and the World Series and stuff like that, and or when you're at Little Brown Jug and they have the odds up there and it's a 6-to-1 kind of thing, they have 6 successes to 1 failure kind of ratio. Okay?